Today we're going to talk a little bit about subsetting. And subsetting is a procedure that we'll commonly use to pre-process data and shape a data set so that it suits our needs for our analysis. In time series data, sometimes we create subsets of recent observations to compare them to observations from the past. We can also use subsetting to eliminate unwanted data, like observations containing missing values, so that omission strategy, low quality data, or outliers. And then in some scenarios, we're working with data sets that we ourselves did not collect or develop to solve a problem, so there may be variables that are completely irrelevant to our issue, or maybe they're redundant, or maybe they're missing a lot of values, and it's just easier for us in our analysis if we get rid of them. We can even use subsetting as part of the descriptive analytics that help reveal insights into the data. So now we're going to dig back into the problem with Catherine Hill and her Asian-inspired meal kits and her desire to understand more about her college-educated millennial customers. So here we are in our studio, and the first step in addressing this problem is to import our customer's data set. So I'm going to go to File, Import Dataset from Excel. I'm going to click Browse, and I'm going to scroll down to this class and open up my customer's data. Your data may be in some other folder on your computer. You just want to go ahead and find where you have this data set saved. And now it's popped up and I can see the data in a spreadsheet format. The name of the file is customers. I'm going to keep it that way. And the first row is set as names, which is exactly what I want. It means that that first row is being used as the name for every single one of the variables in my data set. Perfect. And we can see here in this code preview exactly what the code is going to look like. So first it's going to access the Read Excel library so I can read an Excel file into R. And then it's going to create this data frame called customers by using the Read Excel function and accessing this file on my computer. And then it's going to use the View function to show me a spreadsheet layout of the customer's data set once I click Import. Magic. Now we have our customer's data set pulled into RStudio, and now we can start playing with it. So Catherine is specifically interested in college-educated millennials. So let's first start by creating a subset of just our college-educated customers. So I'm going to create an object called college. So college is the name, and then what I put behind that assignment arrow are the specifications of what I want that object to be. So we're going to pull from the customer's data set, and we're specifically interested in the college variable. We use two equal signs because we specifically want to only include those that have a college education, so college would be equal to yes. And then we put a comma at the end because we want to retain all of that other information, all those other variables for those customers that are college educated. So what we see in our global environment pane here is that we now have this object college with 168 observations. And what that tells us is that 168 of our customers, well, they're college educated. But we're specifically interested in millennials. So we're going to need to narrow things down by birth year. So there are many different ways that we can format dates in RStudio. And frankly, there are many ways to format dates around the world. In the United States, for example, it's very common to format dates as month, day, year, but in other countries, day, month, year is more common. In some scenarios, often with file systems, you may start with year, month, day. So it's important to tell and to explicitly explain to R&R Studio what the format of your date is. I like to tell people that computers are very stupid. We need to give computers very explicit directions on what to do. Computers are terrible at assuming things, so that's kind of why we have to do it. So, college has a number of different variables, including birth date. And we want to make sure that this birth date is formatted as a date, so we use the asDate function. College birth date. And remember, everything in R is case sensitive. And here we're going to explicitly tell it that the format is going to be month, date, and year. And again, remember, case sensitivity, that M and that D are lowercase, but that Y is uppercase. We don't see anything, but we know that behind the scenes that's worked. So now we want to create cutoff dates to indicate the boundaries of who is a millennial. So our first cutoff date is going to be for our oldest millennials. We're going to call it Cutoff Date 1. And we are going to create it as a date, so as date. That will be the format of the variable. And our oldest millennials, we're going to say were born on January 1st of 1982. My husband, born in 1981, would probably be relieved by this because that means he is not a millennial. I, on the other hand, am not so lucky. The format for this date, again, because if we were doing this as day, month, year, it would still mean the same thing, but that's not necessarily the case if maybe our cutoff date was January 3rd, where if it was flipped, it would be March 1st as opposed to January 3rd, 1982. So it's important to explain to our studio exactly what the format of the date is. Same format as before, month, day, year. And now, under our environment pane, we have values, we have cutoff date, and it is January 1st, 1982. And now let's create a cutoff date for our youngest millennials. We're going to call this Cutoff Date 2. It is also going to take a date function. And we're going to go with December 31st, 1999. And this means that many of you watching and in this class probably aren't or may not technically be millennials by this definition. Again, our format here is going to be month, day, and year. So now that we have our college-educated customer separated, and we have the boundaries of what is defined as a millennial established, let's create our millennial subset. We'll call it Millennials. And we're going to pull from the college subset that we created. I'm going to use the box bracket, and again, we're going to look at the birth date value, so college, and then we're going to use the $ for birth date. we want to look at values that are greater than or equal to cutoff date 1, and those that are less than or equal to cutoff date 2. And then we follow that by a comma, and again, that means that it retains the rest of the information in each of those rows instead of just giving us the birth date data. And what we find after we create that is that we have 59 observations of 14 variables, and that is shown to us in the data area of the environment pane. And that is exactly what we were expecting to see. And if you tried to find this number by sorting, you should have found, well, you should have found 59 rows. And while the coding may take a little bit of time to get used to, once you kind of get the hang of it, the coding can be a whole heck of a lot faster than just sorting things. So we've narrowed our data set down to just the rows that we need, but we're only interested in a specific set of variables or columns. So there are two different ways that we can approach this issue. We can create a subset using the column indices, so each column is associated with a number, or we can look at a subset based on the names of each of the columns. And we'll create two subsets so I can show you both approaches, and you can decide what works best for you. The beauty of R is that there's usually more than one way to do just about anything, and I want you to do what makes the most sense for you. I have ways that I'm used to and that I like, but they may not make the most sense or be the easiest for you. And this is all about you. So let's create subset 1 from our Millennials data set. So from here, we're going to pull a couple things from our Millennials subset. C is a command that we use to identify when we want to get a collection of things. So here I want columns 2, which is sex, 6, which is household size. I want 8, which reflects our income. I want 10, that is our 2018 spending. I want 11, which is our number of orders. And I want 14, which is the channel or the marketing method that referred them to the store. And I'll create that subset, and it's 59 observations now of 6 variables. And we can view subset 1 just to see what it looks like. So now we have a smaller and more condensed subset of our data. That customer's data set was a lot bigger, and now we're refining it down to specifically what we want. So let's try to create the same subset using a slightly different approach. Subset 2, we're also pulling from the Millennials data frame. And here we are going to refer to the names of the individual variables. So first we're interested in sex. We are interested in household size. hitting the wrong button. We're interested in income. We're interested in spending in 2018. We are interested in the number of orders. And we're interested in the channel. So now we've created subset 2, and we also find we have 59 observations of 6 variables. We can view subset 2. So now we have subset 2. It's got its 6 variables of 59 observations, and we can hop between subset 1 and subset 2, and we find that they are identical. And that's exactly what we want to see. So R imports non-numerical variables, like sex and channel, as text characters, but these can sometimes be very difficult to analyze using statistical software like R. So we want to convert these into categorical variables or factors using the as factor function. So first, let's look at that sex variable in subset 1. So subset 1, but we're specifically interested in the sex variable. And we're going to make some changes to it. And we're going to do that by using the as factor function. And again, we are converting the sex variable into a factor. So we need to tell it that we want to do that with the sex variable. So I made a typo in this piece of code. See if you can catch it really quickly here. Where I said as dot factor, I said subset. Subset is not an object that we have, so I can press the up arrow and it'll bring back the most recent line of code, and I can drop that 1 in and I can run the line again, and suddenly no problems. And we can see what that looks like. So it looks the same, but now R understands that this is a factor variable, not what's called a string variable. So we could, for example, test to make sure that this is a factor variable by using the is factor function. So is factor subset 1 sex true. So it is a factor. Now we could try this with another variable. Typos are your biggest enemy in R, and whenever you get an error, the first thing you should do is double check your code to make sure that you have not made a typo. So channel is not considered a factor, even though we can kind of see that it's a categorical variable. So we can change that by using that as factor function that we used with the sex variable. So subset 1, channel, and then we're going to use that as factor function on subset 1, channel. And now if we do the is.factor function, subset 1 channel, it's true. So we've changed the structure of this variable to make it just a little bit more useful to us. Now, there was some interest in further subsetting the data set by sex because maybe how men and women shop differs. So to create two subsets of data based on sex, we can use the split function. So we're going to create this object sex, and we're going to use the split function. We're going to split subset 1 by the sex variable in subset 1. So now we see in the environment pane under data, sex is now a list of 2. So now we can look at these different subsets. So here we find we have 21 females, and this is just the first 10 entries of that subset by sex, and we can do the same thing with males. Sex $male. And here we see we actually have 38 entries for males, but we see the first 10. And we see their household size, their income, their 2018 spending, the number of orders, and their referral channel. We can also use the view function to see these things. So now that pops it up in that spreadsheet format in our other window, where it's a little bit easier to see all 21 of the female entries, and we can do the same thing with the males. And we can see all 38 of them in here. So using these subsets, our friend Catherine was able to discover that most male customers were driven to the store by social media advertisements, while female customers were driven more by web ads and referrals. Male customers tend to place more frequent but smaller orders than female customers. So how one might market towards male and female customers probably would differ based on the fact that the channels referring them to the store seem to be a little bit different and their ordering habits are somewhat different. So I challenge you to think about what kinds of actions might Catherine be able to take based on the discoveries that she was able to make just by slicing and dicing and subsetting our data in a few different ways. So think about it, and I'll catch you next time.